All right, so now that we have discussed how we can measure the center of the data, we are going to be talking about something else called a standard deviation. So the measure of the center of the data is an important characteristic of the data, but the standard deviation also tells us a lot about the data. So an important characteristic of any data set is the variation in the data. In some datasets, the data values are concentrated very closely near the mean or the median, while in others, the data values are more widely spread out from the mean. The most common measure of variation, or spread, is called the standard deviation. The standard deviation is a number that measures how far data values are from their mean. The standard deviation provides a numerical measure of the overall amount of variation in a dataset and can be used to determine whether a particular dataset is close to or far from the mean value. The standard deviation is always positive or zero. The standard deviation is small when the data are all concentrated very close to the mean, exhibiting little variation or spread. Smaller standard deviations represent a set of data values which are more consistent with each other. And the standard deviation is larger when the data values are more spread out from the mean, exhibiting more variation. Larger standard deviations represent a set of data values that are less consistent with each other. So let's look at some examples to see how we can interpret standard deviation in some problems. So suppose that you are conducting a survey on how many children each employee has in their households. The mean number of children is 3 per household, and the standard deviation is 1. Jim Bob has 5 children. Describe how Jim Bob's data point relates to the mean. So if I draw a number line here, my mean here is 3. That is my mean number of children in the household. And then my standard deviation is 1. So I would have 4 here, 5 here. That's 2 standard deviations above, and 1 here. Oh, it's 2 here. And 1 child here. That would be 2 standard deviations below the mean. So if Jim Bob has 5 children, that means that he has 2 standard deviations above the mean. So Jim Bob's number of children is 2 standard deviations above the mean. We could also refer to above as to the right, since we are going to the right. Of the mean. So that is how this data is spread out. If you go on to take more statistics classes, you will learn more about how to calculate the standard deviation and what a standard deviation means in terms of statistical analysis. Okay, let's do another example. The College Board analyzed ACT scores in 2015. Scores for the group who planned to apply for financial aid and the group who did not plan to apply for financial aid were both analyzed. Test takers who planned to apply for aid had a mean score of 25 and a standard deviation of 5. Test takers who did not plan to apply for a financial aid had a mean score of 28 and a standard deviation of 7. Which group had a more consistent set of scores? So let's draw some number lines here. Let's draw one for apply, those who plan to apply for financial aid, and those who do not plan to apply. So those who plan to apply had a mean of 25 and a standard deviation of 5. So if I go 1 standard deviation away, I am at 30. If I go 2 standard deviations away, I am at 35. If I go 1 standard deviation below, I'm at 20. If I go 2 standard deviations below, I'm at 15. So this is the spread of data for those who apply for financial aid. What about for those who do not plan to apply for financial aid? They have a mean of 28 And if I go one standard deviation above the mean, since the standard deviation is 7, this would be 35. 2 standard deviations would be 42. If I go 1 standard deviation below, that would give me 21, and 2 standard deviations below would be 14. So which group had a more consistent set of scores? Well, we can see that because the standard deviation for those who plan to apply for financial aid was smaller, the spread of data is a lot smaller, right? So in both of these, I went 2 standard deviations above and below. If I take this number 15 and this number 35, and I see the difference here is 20. If I go to the group that does not plan to apply for financial aid, I have 14 here and 42 here. That is a difference of 28. So the spread for the second group, that group that does not plan to apply for financial aid, is a lot larger if I look at the standard deviation. So that means that the group that planned to apply for financial aid had more consistent scores. The group that planned to apply for financial aid had more consistent scores. Because their standard deviation was smaller. So this is kind of a brief intro to standard deviation. We will be talking about stats for the rest of the term, which is just this week. Hard to believe, right? So have a great day.